Hello class and welcome to section 4.3 of module 4, Linux Overviews. So in this one we're going to talk about Linux servers and clients. Linux networking is one of the biggest strengths of Linux, and one of the main reasons it's deployed so often is setting up Linux servers and Linux clients, but mainly servers is really easy. So we're going to talk a bit about how those are set up and the use cases for Linux servers and clients, and then we'll jump into a lab. So moving right ahead. So an introduction to client-server communications. You can see this helpful little network here, but we have our server where all the resources are stored, and then we have our clients who request the resources over the network onto their device. So either a PC, computer, or a phone. You don't see this as much anymore, but mainly phones and computers. So some provide external resources such as files, email messages, so your emails you get from me, announcements from Canvas, or web pages, all your favorite websites like Merced, citycollege.com or .edu. Other servers run maintenance tasks such as log management, disk scanning, and so on. This is a lot what we'll really enjoy, setting up servers that do just straight up log management, because we don't want to mess with the actual production environment. By throwing our logging systems on it, as I mentioned, you don't want your IT guy to be mad at you. A lot of the times you prop up an individual server that is pretty much listening in at whatever endpoint, and that is actually what's doing all the logging, and then we communicate with that server rather than adding more load to the actual production or even test servers that have the general network flow or resources, etc. of the company. So each service requires separate server software, and the server in the figure uses file server software to provide clients with the ability to retrieve files. So one of the most basic functionalities of the server is storing our files and then grabbing them for our clients, right? So services, and their ports. I'm not going to have you memorize every single port here listed, but you should. I'll point out some of the more important ones. Of course, in interviews, I will say, senior individuals think it's super important to know every single port always, and it does become helpful when you're looking at logs because the only thing listed on the port is a port number. It's not like the explanation of the port. When you click on it in something like Wireshark, sure, it'll tell you, but the idea is that you could glance at one of these files on your Linux system and be like, oh, that's where it's connecting, right? So the ones you'll see a lot is FTP. So this is us moving our files around. This is not super secure anymore, generally used only internally, and really shouldn't be used internally, but we still do. Secure shells, this is being able to remote in pretty much to a Linux system. You see this all the time. Telling that same thing. Obviously, we have our mail transfer. This is for DNS. And then DHCP, so more networking and configurations of our IPs and domain names. And then another important one is 80. So this is pretty much every time you have a web connection. So your HTTP, Google, etc. And then again, depending on what email server is on your networks, you might see some of these other ones. So IMAP or POP3. And then another important one is HTTPS, because a lot of the websites we sign into now are not just on port 80, but they're actually secure, which being security people, we like seeing 443 ports rather than port 80s. These are generally for local connections or local servers. So clients, talked a little bit about servers, so let's talk about the clients. The things on the other end are a fantastic phone that is uploading files somehow. This must be a powerful phone. I'm not entirely sure. I guess maybe voicemail. Anyway, so clients are programs or applications designed to communicate with a specific type of server. Most of the time, they communicate with many different types of servers, but if you have specifically a client built to connect to a server, that's kind of what this is more talking about. But as we know, like our smartphone being the client, we have tons of different applications that run on it. And then those applications are really what it's talking about, is like the specific client is the specific application on your client-side phone, right? So web browsers are web clients that are used to communicate. So your Chromes, your Edges, your Firefoxes through port 80. Again, a lot of the times it's now on 443. We're not on port 80. Here, I'll go back really quick. So you can see secure, but there's still, there's still connections port 80. Generally, if you are connecting like this, Google or whatever will give you a big flag saying, hey, your connection is not secure. That's kind of what it means. It's a few different reasons, but that's one of them. So FTP, there's a secure FTP version in the same way that we have like the insecure version of port 80. And then for FTP, there's secure FTP or FTPS. And then the figure shows clients uploading files. So again, I see this as voicemail. This is, pictures of your dog, or, you're uploading your homework to Canvas. So, okay, this is lab. This was a really quick section. So let's just go in and jump in this lab real quick. All right, here we are. We're just going to touch very, very gently on our services and servers that you can run on Linux. So go ahead and log in. You're going to see what's connected and what's already running. You'll also notice that there are things running on this that you wouldn't see on like just a blank distribution. That's why it's kind of a special edited distribution. We talked about that a little bit before. So we took Kali Linux and we added some of the functionalities and like pretty much dummy connections, etc., so that you can see them and explore them. That's why we're using this one in particular, not like you can't just go grab Kali Linux. That's why you needed this image. Again, you can find it on Canvas. Hopefully that's already installed and good to go, because we're in week 2 now. And as I mentioned, class moves fast. It's a accelerated course, and we have lots of really good content to get through, especially if you're preparing to take a certification, the associate certification, CyberOps associate. Got to get through all this good stuff so that this class can kind of act as a study session, and then when you're really sitting down, go get the cert, it's just review, right? Rather than new stuff. So go through the lab. Again, I only need quick answers here. I don't need an essay, just enough to get the point across, and then your reflections. You can maybe be a little more wordy with the reflections, as it is kind of asking you to think critically rather than just like, hey, what do you see on the screen, right? Okay, so let's go into the next section. All right, here we are, basic server administration. So we got our server set up. We are playing with all of our services. We got our clients ready. Now we're going to actually do some administration. This is where the magic happens in terms of making sure people aren't breaking our servers. So let's go and move into it. So config files, this is really just setting up the service. What kind of clients can it talk to? When is it running? Is it running on startup? Is it running when something else is, requesting it? Sometimes they sleep until a request comes in and the server wakes up the service, right? So when the service starts, it looks for its config files. Again, pretty much everything runs off config files, which is why we want to be familiar with text editors. So once it starts, loads them into memory, adjusts itself according to the settings in the file. So the command output shows a portion of the config file for Nginx, which is a lightweight web server. So you'll see this a lot for deployment of web servers. So the command output shows the config file for network time protocol. So again, we're seeing how our NTP is set up, and then here's all of our, our server pools here. You can see Archpool, NTP, org, etc. And if we're trying to say connect to server 4 and it's not showing here, we can go, oh, okay, because it's not configured. So a little more shows a configure file for Snort, which is kind of used for watching for intrusion. So you can use Snort to pretty much look over all of those log files of network activity and traffic. And then Snort will help sort and show you like, hey, this is abnormal and this happened here and you should look at this because at 3 a.m. someone downloaded your entire, repository, whatever, right? So hardening devices, this is a really important term. So if you get something from this lecture, hopefully it's this, is hardening devices is what we do often as security individuals. Is we go in and we take these base configurations, these base images of Kali Linux, these base images of whatever Linux distribution our company is using, and we harden it to reduce the attack surface and make sure our developers, operating system developers, are aware of these issues. Often through hardening, you'll do testing, you'll try to break it, you find a way in, you report that to the OS guys patch it, rinse and repeat. It's kind of a constant game of cat and mouse of trying to break things, and that's part of the job. Is you get to be the guy who breaks things, hopefully, not horribly broken, but just finding those holes and patching them before someone else does is kind of a big part of what we do. So here are the best practices for device hardening. Everybody kind of has their own list. Every company has their own things they focus on, but I think this list is really good and kind of like covers a lot of your bases. So physical security, not letting people in the building, so your door locks, etc. Minimize installed packages. The more packages, the more vulnerabilities. The more patches, the more etc. Only have what you need running. That's again why we love Linux, is rather than having a computer that has all of our different apps and all this different stuff, we just remote into one Linux shell. We install the one service, and that is what that Linux shell does, is that it's that service, right? And then we do a different server, log into that shell, that service. We don't often try to make something this jack of all trades in the same way, say, a Windows server could be. But sometimes it is just you have a physical server with one Linux distribution, so yeah, you install more on. But generally, trying to partition it out is a good idea. Segmentation. So disable unused services, again, minimizing our attack surfaces here. If it's running, there's potential that someone could use it and get in. Use SSH and disable the root account. Log in over SSH. So this is pretty much preventing someone from going in remotely and getting onto the root. If you want to get on the root, you got to be physically at the system. That's kind of where that console is, and you might see in the Mission Impossible movies, they break into the room and there's that one little keyboard in the corner and they type super furiously, and they're in. Generally, it's because you can't remote take over because the administrative privileges, more specifically the root, is locked behind either a physical connection or just disabled entirely. So keep the system updated. As I mentioned in the Windows section, do your updates, because in the previous slide we talked about our job is to find things to break, and once we figure them out, generally the world does. So if someone is a malicious individual or actor, they're often watching for the patches to see what we fix or notice, and then they'll try to go after people in that downtime. So being up to date as soon as things launch is a really good, that lag time in between. It's a good habit to get into. So disable USB auto detection. This is to keep someone from just walking by and plugging a USB in, and it has whatever horrible malware on it. Enforce strong passwords. I'm sure all of you have worked at a job or a place where you had to have a login, or even just like a website. And before, our passwords used to be like, just enter something, there you go. Now they're like, okay, how about 8 characters? And now they're 8 characters, a special symbol, and a number. And now it's uppercase, special symbol, a different language, a few different pieces of your DNA, etc. It is frustrating, but with how fast computers are getting and how easy it is to crack passwords, the more complicated, the better. We're kind of moving away even from 8 characters. We're moving up to like 12 and 16, but 8 is still kind of like the bare minimum character count, with as long as it's mixed, symbols, upper, lower. So passwords are more important than they really should be. There are some places trying to establish solutions. You've probably seen like OneLogin or whatever. Because we are not meant to memorize, 80 passwords for the 80 different websites we go on. We use the same one, and then that becomes a problem. So periodic password changes is to prevent you from using the same one for everything, because you're constantly having to update them. So again, get yourself a password manager. There's tons and tons and tons of them, and they encrypt themselves on your phone. So if you even lose your phone, it's locked up. So keep users from reusing old passwords. I just mentioned we're if we can, we probably would, right? Just because it's easier and it's one less thing to remember in our busy lives, but it is a big security problem. So monitoring service logs. Again, we love our logs. That pretty much tells us when things go wrong, and that's generally what we're looking for, is when things go wrong. So here are some of the different log types you saw it in the Windows event viewer. They also have services, systems, events, and application logs. Same thing here in Linux. We kind of have our 4 like big categories, and then learning which logs have which information. So again, if you're looking for a services information, you might not find it in the application log. You're going to find it in the service log. So now knowing which logs to go and dig into is an important part of Linux administration. So the following table lists a few popular Linux log files and their functions. So again, I'm not going to go jump into all of these, but pretty much here are some of the big boy logs that we want to go ahead and grab when we're building our scene, or the first thing we go and look at when we're like, hey, who broke into our system. So check the boot, check the who's been authenticated, the messages that have gone back and forth for generic computer activity, right? And here's some more. So kernel log, see if something blew up when it was going on the kernel, or if something has access to the kernel, which could be really bad. And then, so you can see here, we're going to do this in the lab, but you're going to see here's an output, all the messages and things that went through. You're going to see this in the lab, and there it is. So let me go and pull that out. So as you can see here, the lab is called locating log files rather than like becoming an expert at log files. This is really just, hey, where are they? Because again, you won't know which logs to grab if you don't know where they are and if they even exist. So these are some of the logs that are going to be your most important ones. We're going to go over kind of like where an application or a service generates a log. So we're going to go through, I think here. So here's our web server, right? And then here's our operating system log. And then locating logs in unknown systems. Again, you're going to be using a lot of unknown systems. You walk into say you're trying to figure out what happened in a place. You don't know the system. You don't know where all the logs are. So it's very helpful to kind of figure out where logs would generally be placed and start looking from there. Of course, you can see the endings of .conf, so our configuration files often will say its access log file is here. So you can check how it's configured, whatever application you're looking at, and then it'll tell you, oh, hey, I'm dumping my log here, right? So sometimes you have to go all the way back to the actual problem child or service or whatever, and then see, okay, it's set to go here, and then I go wherever they're dumping their logs, because most applications and programs, they all choose their own place that they want to dump them. So anyway, this slide's a little longer because log files are they can become very long. That's why we use a lot of different softwares to kind of trim down all that fat and just grab what's important. So anyway, I'm going to go through all the different kind of logs. Most of it's just screenshots that are making this look longer, but that's it. And there's no really reflection here. You just log files are extremely important for troubleshooting. I mean, I don't know what else I would do without them, because if a thing just flashes and dies and just like, oh, okay, I guess the program doesn't work. Without a log file, I have no idea what's going on or what I need to change, right? So log files are kind of our gold mine for information. All right, let's go back to the lecture. All right, we are back at the lecture. So we're going to talk about the file system. We mentioned it briefly in the Windows section. We're going to talk about it a little more here. We're over halfway through the Linux overview, so hang in there. We're getting through it. So the file system types in Linux. There are many different kinds of file systems varying in properties, speed, flexibility, security, size, structure, logic, and more. Yeah. So our X2, you're going to see a lot. Previously, a lot of old distributions still run it. X3 came out and it was, the bigger and better. We have X4 now that is used sometimes just because it is new and it's stability issues, right? So new means problems, as I mentioned with the Windows stuff. We get lots and lots and lots and lots and lots of new features that blow up lots and lots and lots and lots and lots and lots of things. So a lot of people are still on X3. That's pretty much what you'll see for the most part right now. X4 is starting to become more widely adopted, as I assume we're going to get X5 next few years, and X4 will be the more stable one, X5 will be the less stable one, and if you want to guinea pig it, great. If you'd rather it be more stable and you're used to this file system, great. But you might have security compliance things that say, hey man, you cannot be on X2 anymore. They have this, and this issue. So you have to make the upgrade, right? So sometimes your hand is forced, or you're the person telling individuals, yeah, no, man, you can't be on X2 anymore. You got to go up. So we talked about the network file system. This is so our Linux servers can have files that are stored, and then our Windows machines can see them easily, grab them, etc. And I believe, thanks to the Linux implementation for Macs, the newer ones, they also can read network file systems. This is for if you're deploying an operating system mainly, is you stuff the entire operating system on a disk rather than on a hard drive, and then you can launch off of a disk on whatever console or physical machine you're at. You don't see this that often. Swap file system is used by Linux when it runs out of RAM. This is just kind of how it cheats its performance, puts RAM away by physically storing it and then moving it in and out of the actual RAM. Is really cool. Again, you won't see this too often because it's way slower, because it's using the physical partition, the physical media of your hard drive. So you don't really want this to happen. But say you're starting to use a ton of RAM, but you have a ton sitting inactive, it'll move it out and try to make that active RAM for the more active processes. So just a good thing to know that it can do. So HFS Plus, this is our Apple thing, file system. We talked about this. HFS Plus, again, because of the Linux kernel implementations with newer Macs. HFS Plus has also used on older Macs too, but pretty much the Linux kernel tries to play nice with both Apple and Windows. It's kind of like everybody's friend, right? Because it doesn't know what it's going to be working with. So it allows you to read write. It doesn't do a great job of all of the cool Apple features on their hard drives. which is the APFS, but it's like, you know what, at least we can talk. Texting that guy who still has the flip phone, but at least you get the message through. So the Apple file system, not really a focus of this class, or Windows, Linux, mainly Linux. It's very cool. They have a lot of really neat proprietary tricks they do with their hard drives because they control the hard drives file system and their OS, and everything is very ecosystem versus Windows, who's trying to work with everybody who will their hard drives, etc. Apple is very picky and allows them to do some really cool optimization on their hard drives. Some of the time machine thing, which is where you can do backups of your computer and almost like a snapshot, fall back to it. I find that to be a little more efficient than the Windows backup version. Windows backup is fine, but the time machine is so seamless comparatively. So anyway, that's kind of through the magic of their file system here. And then your master boot record, talked about this a little before. It's our very first sector. It's what's in charge of kicking up the actual operating system to be operating, right? So mounting, that term comes from, we have, as I mentioned, the server racks. When you slide something in, they're called mounts. So you mount a drive or you mount your blade or whatever. So that kind of, we do a lot more digital mounting now, where we have our, digital network drive that we mount onto our system. And it's pretty much just saying, hey, this part of our partition is going to talk to this server, or I'm sorry, this hard drive. And this is where the information will flow back and forth. And then when we dismount it, that partition is either cleared or reassigned somewhere else, or it's just left dormant. Okay, so Linux roles and file permissions. This is some of the administrative stuff. We talked about server administration, so this is more of the more local system administration. So you'll want to become familiar with read, write, execute. Those are your big three permissions in terms of, can you look at it, read? Can you write on it, which is change it, right? And execute means actually run it. So if it's like an exe or an application. So ls command or list command with the parameters of, this is an L parameter, lists additional information about the file. So output of lsl command provides a lot of information about the file space.txt. So you can see here, we have the dash rwx rw dash r dash dash. We're going to talk about what that means exactly, but these are, if you kind of notice those three words, read, write, execute, read, write, execute. Those are the letters we use as our shorthand of it. So you can see here with the additional information that is being given by our parameter here, we get to see exactly how big it is, who owns it, right? The group staff here is the owner, and then how big it is, so 253 bytes. So just good information. So here's, as I mentioned, the read, write, execute powers or permissions. So the dash means that this is a file. So it's either a file or a directory. So dash or D. So you'll see a dash or D at front. So you can have read and write permissions even in folders or directories, I should say. So reading, writing, and execute, you can see the user here, analyst, so RWX. So I don't think they have the whole thing here. Yeah, so you can see here, I'll just go back and forth. So the first three are our user permissions, our next three are our group permissions, and then our last three are our other permissions, which is, depending on how you configure it. So you can see here, right, so our user can do everything. They can read, write, and execute it. Our group can read and write it, so we can look at it, we can mess with it, but the group does not actually have the power to run it. And then the other category can only read it, so they're not allowed to mess with it. They're not, they don't have the permission. So the third set of characters is for other user or group permissions we can only read. So someone who is not the user, someone who is not in the group, they fall in this third category. They can only look at it, which is read. So octal values are used to define permissions. A lot of the times you'll just see this set. So 111. 111 means you can do everything. And then if you know how to read binary, these are the numbers pretty much translated all the way up to 7. So hard links and symbolic links, this is kind of how you store things on a hard drive. So a hard link is another file that points to the same location as the original file. So this means directly pointing. So use the command ln to create a hard link, the first argument in the existing file, and the second argument is the new file. So one file pointing at the other pretty much, right? So both files point to the same location in the file system. That's how it's stored. It is physically there, right there in the file system. That is what a hard link is. And you can see that code command is used to add some more text. So a symbolic link or a symlink or a soft link is similar to a hard link that applying changes to the symbolic link will also change the original file. As shown in the command output, use ln options -s to create a symbolic link. Notice that adding a line of text, test.txt, also adds the line to my text.txt. So the hard links is difficult because things move around so much. Files move here or there, somebody's messing with it. Hard links are, if you move anything or anything changes in the file system, it'll break. So we typically use soft links, but hard links are helpful when the configuration is going to change at all, right? Because hard links are limited to the file system in which they are created. So a symbolic link can be used when you're talking through that, network file system that is a little different. It's from your Windows server, whatever, right? You don't want to have all these hard links because they aren't going to point correctly because it's in a different file system. So hard links cannot link to a directory as the system itself uses hard links to define the hierarchy of the directory structure. So symbolic links can link to directories. So you can actually say, hey, anything here that's changed it in that directory as well, rather than that specific file, which is what a hard link would do. So rather than just hearing me talk about it, let's go and jump into a lab where we're going to go with some of the file system information. All right, so this is our last lab of this section. The rest of the lecture is just kind of going to be a little more, I guess, cyber focused and some just like helpful information. Not a lot that's really, hands-on. So enjoy this last lab of this section. We're talking about the Linux file system and permission settings. I mean, that's one of the things you'll do a lot if you do any sysadmin work, is going through the file system, setting permissions, and ensuring users can access what they need and access nothing else. Pretty much, we want to use least permissions. We don't want people to be able to access everything and only like blacklist user 1 and 2. We want everyone to have no access to except the explicit things that they absolutely need for their job function. So same thing here, just a few questions here, stepping through the lab. There's no really gotchas here. So again, there's no reflection. So pretty much just step through the lab, get a little familiar with it, a little more comfortable using Linux before we go into the more complicated labs and doing our own kind of configuration settings. This is more just kind of seeing, oh yeah, this is what's set up, this is how the file system works, etc. So let's go and jump back into the lecture. So almost done. 2 more sections here. So working with the Linux GUI, as I mentioned, there's no more labs. This is what you're going to see when you're messing with it. You really don't need a lab for the GUI because most of you use a GUI and pretty much every time you log onto your computers because it's just kind of how we interact now with our computers. Is everything really is not on a CLI. Everything has its nice, pretty graphic user interface. So that's why the Linux transition for a lot of people can be a little difficult when you're getting used to all that CLI work, because all the pretty, images and symbols are gone. And I'm not going to say I enjoy the CLI more. I don't think many people do. If they do, then great for them. I think a lot of us enjoy a GUI because it is designed for users, right? We are the user. So anyway, here's just a little simple information about the GUI. So it's based on the X window system. X window, also known as X or X11, is a windowing system designed to provide the basic framework for a GUI. So pretty much trying to give you what you see in Windows, right? We're going to use the X window system. So X works as a server, which allows a remote user to use the network to connect, start a graphical application, and have the graphical window open on the remote terminal. This is very helpful for when you are doing management of other Linux systems and you want to look at the GUI rather than look at a command line. So X works very helpful. So examples of Windows Manager are GNOME and KDE. So you can see here, we can take a look at all of our different functionalities, our mail. You can see someone's writing an email right here. So the Linux GUI, as you've seen it when you logged in, so we have, our kind of general turning it on and off, checking our Ethernet, changing volume, top bar, time, etc., and then our apps menu, and then pretty much it. I'm not going to go through all this because again, it's just what you already are using. So if you want to pause me and read it, feel free. It's pretty much just, hey, this is the GUI and how it works. I recommend you explore it a little bit on your own. So working on a Linux host, which is what we'll be doing, installing and running applications on a Linux host. So I know a lot of people have problems when they're first installing things because, again, it's not just a double click wizard pops up. You have to learn some of the like application parameters and things we need to do to actually get it to install and run correctly. So your kind of go-to sudo apt-get update, this just checks to make sure everything you have is going to be up to date. It's important that a lot of servers run this automatically just to keep themselves up to date, say at midnight every night or whatever, depending if they're on production servers or not. So apt-get is kind of our way to acquire new applications. So keeping the system up to date, as I mentioned, it's important to not let your system become out of date, because when vulnerabilities are discovered, it's not just you, it is not just the good guys, but the bad guys as well. So modern operating systems will alert the user when updates are available for download, but the user can check for updates at any time. The following table compares Arch Linux and Debian Ubuntu Linux distribution commands to perform package system-based operations. So again, we're using this, but Arch is also popular. And by this, I mean the Debian Ubuntu. So Linux GUI can also be used to manually check and install updates. So you can search for software updater. Again, they really have come around into making it pretty much a fully GUI. Like you don't even have to use the command line in Linux anymore. It's pretty great in terms of that. But again, I do not recommend that you get comfortable with this, because this is familiar. I want you to try to update your applications excuse me, through the command line and do these functionalities through the command line. So processes and forks. A process is a running instance of a computer program. Forking is a method that the kernel uses to allow a process to create a copy of itself. So if you think of the structure of a fork, or if you've done any work at like GitHub, etc., you have your straight line and then it breaks apart. So it forks, like a fork in a road, pretty much from the same process and then two separate instances. When a process calls a fork, the caller process becomes the parent process, the newly created process becomes its child. So after the fork, the processes are to some extent independent processes, but they are still linked from who is the original creator, who's the bottom part of the fork, and then who are the other sides of it, right? They have different process IDs, but they run the same program code. So they're still related, like parent and child, but they are, different individuals. So the following table lists 3 commands that are used to manage processes. So kill is how we turn off our commands, or our processes. It's kind of the equivalent of going into Task Manager and doing, end task. It's how you put a process down, and then PS is used to list the processes. So it's kind of your LS, right? So we see our list of files. PS will show us our list of processes, and then top used to list running processes, keeps displaying running processes dynamically. This is like opening task command, right? You can see all the processes running rather than just like, here's a list. This is like, oh, hey, here's the list, but also what's going on with them. So the command output shows the output of the top command on a Linux computer. So you can see we're actually getting like dynamic information here, how much of the virtual memory is being used, PID, and you'll see this move up and down, and kind of like looking at task command. So malware on a Linux host. So Linux malware is dangerous because, again, Linux is so lightweight. It doesn't have all the security functionality. It doesn't have Windows Defender. You have to install your own, defense, which we'll talk about obviously in this class, is how to harden machines. And Linux machines do not come pre-hardened for the most part. They come very open, which is part of their power, but also part of their vulnerability. And then rootkit check. So rootkit is a type of malware designed to increase an unauthorized user's privileges or grant access to portions of the software that should not normally be allowed. So again, we don't want anybody running as root. Root should really just be to set up the computer, and then after that, root goes away. Root is not used or disabled, and even if you're doing admin work, you're using a user who has super user permissions, not on root. Creating a new account is pretty much the first thing you do with root, and then you never touch unless absolutely necessary. So rootkits are trying to become a root user, right? They're trying to make their user root. So that's where the term rootkit comes from. So piping commands. This is, rather than having to type one command and then copying, the output, you can have one command's output be another command's input, which is pretty much what piping means. So it's a technique for complex tasks, but it's just taking the information you get from one command or the output of one command and saying, hey, use this as my input for this other command, right? So it's chaining commands together rather than, again, having to type separate commands, adding the input yourself. You could just say, hey, do these two commands in this order, and then this output will become this input. So kind of like a pipe, you put things in one side, comes out the other. So the input on the left side of the pipe will become the output, or the output of the left side of the pipe will be what's input on the next set of instructions. So video demonstration, you can go ahead and watch this on the Netacad. I'm not going to rip the video like I did last time, just because you guys should all be on Netacad. If you're having problems signing up for it, let me know, because there's tons of good information there, especially for studying, and of course you need to be on Netacad to take the exams. But just go ahead and go to section 4.7, watch this video, please. It's only 4 minutes. And then, so we've reached the end. What did we learn? We've learned all of Linux. I wish that was the case, but we've learned a lot, and we've learned what we need to get to the starting line and really begin to utilize Linux in a cyber environment for operations at a SOC. So really quick, because I know this has already gone long, it's fast, reliable, and small. Those are the 3 best parts of it. And open source is also helpful, but of course with open source comes lots and lots of vulnerabilities, so always be very careful. Harden your systems. There's servers, there's GUIs, there's console-based ones. Linux comes in all shapes and sizes. Config files is pretty much what rules the entire Linux distribution, so being familiar with the ability to edit them through things like Nano, any text editor you want. There's a lot of different file systems, but again, we generally are sticking to X3. X4 is also helpful, depending on, if you're willing to take that little step into maybe less stability, but a lot more functionality. And then the X Windows or X11 system is basic software framework. That's kind of what's used to make the pretty GUI in a point and click interface. So you'll see that when you log in. And that is it. Good job getting through this section. Let me know if you have any questions, comments, concerns. Linux is kind of the king, in my opinion, when it comes to our industry. Windows is what you'll use a lot at home. It's what you maybe will use in the office on a computer. But when you're actually diving into your distributions, when you're diving into your live processes and production pipelines, most things, most servers, most services are going to run on those little Linux systems. So being familiar with how to configure, maneuver, and operate Linux is vital for this industry. You can't really get away from it. Linux is hand in hand with this entire industry and many industries, but I would, again, greatly encourage you to take just 10 minutes a day, mess with some Linux commands. There's some even fun like Linux command games that you can even do on your browsers, on your personal computers, that kind of like have you practice moving a file somewhere, and then if you do it fast, you get a gold medal, etc. I'll see if I can find some of those and put them in the supplemental information or supplemental content, but I think just doing it on your actual VM so you become familiar with the VM you're using for all these labs is probably the best. But anyway, that's it for me. We'll see you guys in the next one.